Hello everyone, this is Peter Online Computer Network Engineering Tutorial. I am here to introduce Rapid Spanning Tree Protocol to you, okay? Unlike STP, that's Spanning Tree Protocol. This is the latest version of this, okay? And they have similar functions, okay? They have similar functions, but the difference there is this converges networks so quickly because in the process of trying to prevent loop, spanning tree protocol uses some kind of things to prevent this loop and which will cause network convergence to stay up to 50 seconds. Network convergence is a process of, trying to come up, for network to come up, okay, from transitioning mode, okay? That is, let's say this root bridge here, let's say this is a root bridge, it fails or any link fails, okay? Remember the bridge protocol data unit which I mentioned about, which is messages, hello message from the root bridge to other switches, okay? That message is to, trying to know the status of each link and switches. Okay, so from root B, send this message, bridge protocol data unit. Now, let's say if a particular link fails, okay, bridge protocol data unit will be sent 10 times, and each one takes 2 seconds to be sent. And when this link refuses to reply, it will be considered that that link is down. So, the topology will change. Let's say from this root bridge, the link, which is the designated port, let's say this is DP, designated port. This designated port may end up being blocking port if topology changes. And it takes like 50 seconds in STP for topology to change, and which is considered a lot of time because considering the kind of applications that are running on network, like some critical network infrastructures, okay, where you have some applications that need network-based applications that need to come up immediately, even if there is changes. So waiting for 50 seconds, that application might declare timeout, okay, which is not too good. And another thing, let's say the MD want to send important mail to his own counterpart in another company. Maybe they have, business related, issues or such, you know, discussions, which you need to send the mail. And that time, network is about to, change topology. Okay, spanning tree issue. It will wait for, which means the end they need to wait for approximately a minute to send this or to open the email browser or email application, which is not too good for network administrator. Okay, so what you need to do, you configure spanning tree protocol. Okay, spanning tree protocol, spanning tree, rapid spanning tree protocol, converges so quickly than STP. This is a new one. It converges approximately 6 seconds and all is done. But remember, STP possesses some kind of features like blocking mode, blocking, okay? Because when topology want to changes to another, changes, when topology changes, maybe there is a link failure and topology want to change. Remember that STP uses some kind of four port mode, okay? Blocking, okay, let's start from listening, listening, listening mode, okay? Now, listening, learning, learning, okay? Forwarding, forwarding, and which again, that STP uses. Let's say blocking. About 5 of them disabled. Disabled. But this disabled is more or less like this, blocking. But why rapid spanning tree? Because all these processes need to, pass through, okay, before the topology changes, which takes about 50 seconds for these things, for switches to go through listening, learning, and forwarding mode. Okay, but in rapid spanning tree protocol, there is nothing like listening. This is cancelled here. Okay, and this is cancelled. Learning is cancelled. The only thing you would see there is let me list it, is, learning. No, learning is not, this is, okay, you only have 3. You see learning process, okay, you will see discarding, you see forwarding. In rapid, it has learning, discarding, and forwarding. But why STP has these about 5 thought mode, which you need to go through before transitioning. Okay, so now we do this under 6 seconds, while this takes 50 seconds, which makes this to be the best. Because in a critical network infrastructure, okay, in a switched network infrastructure, we don't want a kind of, almost a minute before the network will be converged. What if something important wants to be done at that particular time, which means it will take that system or their user a minute before doing that thing? What about backup file? What about things that needed to be done within some seconds? Okay, so we don't need that delay. And remember, this delay, in a process of all this happening, in a process to prevent loop. So, and there is other things you can configure in order to make, convergence, for network to converge so quickly. Because the difference between this and this is convergence. This converges 50 seconds. This convergence converges almost immediately. There are other features of these two, switching protocols, okay, which is called ether channel. Ether channel. Ether channel. Okay, port fast. Port fast. Okay, and these things, another thing is bridge protocol data unit guard. These are, sorry, my marker is not showing well. So when you configure these things, ether channel, which means there will be nothing like convergence. Immediately topology wants to change, network will just converge in 1 second. When you configure this ether channel is linking of 2 or more, links, like these links now that goes to this port. The maximum is about 8 links. And let's assume each link from this switch to this switch is about 1 gigabit per second speed. Now, by linking about 8, which means 1 gig times 8, which means you have created about 8 gigabit per second speed. So when you leave it, you don't leave it this way. If you leave it this way, STP will block this, and leave this. And we don't want STP blockage. Okay, we want the network to converge almost immediately. So what you need to do, you configure Ether-channel protocol. By the time you configured Ether-channel protocol, Ether-channel protocol is where you combine this, okay? You combine these three links into one. So which means when one fails, one is still on, others are still on. So nothing like downtime here. It's only when link fails that you have downtime. Okay, and having that time will now cause the network to change topology, to do re-elect, to choose another root bridge. Okay, and in the process of doing that, in STP, which means it counter like 50 seconds. In rapid spanning tree, which is RSTP, counter like 6 seconds. But when you configure one of these things, Ether channel, port files, and this, the network converges immediately. Okay, it converges immediately. So that is it. And in order to configure this, you can say from global configuration mode, you configure, because this port fast, this Ether channel is configuring several links. Bond it, that's to bind it to get one, to form one. Okay, you can do that here and do this side. These are network cables. We channel them together, all these cables. But port fast, you can choose this. This is the most common, which from global configuration mode, they do this spanning tree mode, spanning tree, sorry, spanning tree, okay, mode, spanning tree mode, okay, V mode, you put this, okay, port fast, pavilion spanning tree. You hit enter. And before you configure this, you don't configure this on these links. You don't configure them on links. No. The best way to configure this, you look for a server. You configured it on access port. Let's say this is access switch where um, nodes or servers connect to. So you configure this on server. Okay, this is a server here. Okay, and it's FO/2. Okay, it's FO/2. What you need to do is, disregard the earlier configuration, the one I just cleaned now. So all you need to do, so that nobody goes there, make sure that nobody touches this server. It's always connected. And this server must be in the IT room where you are. So making sure that nobody touches this server or trying to remove the STP cable, the RJ45 cable from the switch port. All you need to do, you do this from global configuration mode, interface FO/2. You hit enter. Then spanning tree mode. Okay, you put this port fast. Sorry, port fast is together. Sorry, let me change this. Okay, port fast. Give this pavilion spanning tree. You hit enter. So when topology changes, you have configured this. When topology changes, okay, and it changes almost immediately, okay, because of what you have configured here. And nobody touches this, okay? If you configure this on these links, okay, if you configure this on this link and there is link failure, okay, it changes the mode back to the original mode. okay, and which there's a tendency of loop to occur. So the best place to configure it, look for an end user device around the access switch, access port, if it is a computer or a server that you know that is there permanent, configure port fast there. So that whenever there is topology changes, it converges immediately. Okay? We don't want to see any slow convergence in our network infrastructure, which may cause so many things. Okay? So that is it. If you find this interesting, do not hesitate to share. Thank you and see you in the next tutorial.